Hello, welcome back to AP Pre-Calculus. This is lesson 2.8, part 2, inverse functions. All right, let's go over what's on this page. Some of it is review, some of it might be a little bit new. All right, so we have if f and g are inverses of each other, then g of x will be equal to the inverse of f of x. If xy is a point on the function f of x, then yx would be a point on the graph of g of x. Because remember, all we're doing is switching x's and y's. So if this is a point on one, then this would be the point on its inverse because we switched the x and the y. With inverse functions, all of the x and y values are switched, so the graphical behaviors in the terms of x and y will also be switched. For example, the domain of f would be the exact same as the range of the inverse of f, because domain is your x. If I'm doing the inverse, I switch them, so all these x numbers become y numbers, and y is range. Last, a continuous function will only have an inverse function if it is strictly increasing or strictly decreasing. So I can't have any change in increasing to decreasing or decreasing to increasing. If a function changes from increasing to decreasing, it will not pass the horizontal line test. Oh, that's a new one. We know the vertical line test. And that tests to make sure that for every x, there is only one y. And remember, if I'm talking about an inverse, then I could change those x's and y's up and say, for the inverse, for every y, there can only be one x. So, and that would be a horizontal line test, okay? So that's the way we can look at a graph before doing too much work and saying, hey, I wonder if the inverse would be a function. Well, if the original graph doesn't pass a horizontal line test, then the inverse would not pass the vertical line test. All right, we've seen these before, but this one's a little bit different because I have a function f of x up here. This is your y value, remember, right? And I got a table of values. But you'll notice down here we're talking about g's and some of these, like I got a g. And if we read the problem, it says g of x is the same thing equal to the inverse of f of x, okay? So we're going to come back to this when we get to the ones that have the g. So let's do a couple of these. All right, so remember, you start on the inside and work your way out. So I'm starting here with a 0 as my input. So I go up to x, I find 0, I get a 1. So that becomes the output, but it's still in a parentheses. So now I go find 1 as an input, and I get -1. All right? G. Well, I don't really have a G to look at, so I'm going to do this. F -1. This is the same. These mean the exact same thing, okay? So what does that mean? Okay? So what we could do is we could think of this. Remember, this is the inverse, so this changed my x and my y. So what would this have been? Because it's the x now, so what would it have been back in the original function? It would have been the y, right? So if it's the y, I should look down here and find where is the -3, and I get 4. So the inverse function would be 4. F -1 of -3, the inverse of f at -3 would be 4. Okay, let's do it again. F -1 of 6. So I know that if that's the x here in the inverse, it must have been the y in the original function. So where is that a 6? I see it, it's right there for the y value. So my answer is -3. Okay, moving on. Oh God, this one is, I'm going to write it a couple times. F -1, F -1 of negative. That's a lot of -1s. All right, remember, if it's the x here, it must have been the y here. So where did we get a y of -1? So we're looking at all the y's. Oh, we got it at 1. So I can fill in the 1 here. And remember, if this is the x here, it must have been the y in the original. So we're going to go back and look at the y's. I see a 1. I must have had a 0. So my answer is 0. All right, last one, because f is the same thing as b, so we're not going to do that one again. So let's see, f -1, because I don't like the way this is written, I'm going to rewrite it, f of -2. All right, on the inside, it is not an inverse function. So I have the f function. So this is the input right here. So I'm going to go look at my inputs. I got -2. My output was 3. So I have f -1 of 3. Remember, if this is the input on an inverse function, it must have been the output on the original function. So let's go back to the original function. The output of 3, the input must have been -2. So it's -2. Okay. All right, let's look at a problem graphically here. So we have a graph of k. So the function is k. And it is asking me, what is the minimum value of k? Remember, minimum value is your y value. And since it's given to me, it's not an inverse. We just look for the lowest point, and we have it right there. So that my minimum value is -3. What would the minimum value for the inverse be? Well, remember, we would switch our x's and our y's. So if I think about what is the smallest x value on this function, when I did the inverse, it would turn into the y value. So the smallest x is the same point, but the value is -4. So the minimum value of this one is -4. All right, how are we going to do this? Find the inverse of the k function at 6. Well, remember, just like the last one, if this is my input into the inverse, then it must have been my output on the original function. So for my f function, where did I get a y of 6? So if we look this way on our line, and we're looking for where it would be 6, here we go. I see a 6 way up there. I go over, I find the graph. There's my point. I drop down, and I'm at 11. So this would be 11. So the value would be that. All right, let's try again with this number. All right, so if it's the input on my inverse, it was the output. Let's go back. Let's look for 4 this time. 4 is right there. Go find the graph. Oh, there it is. Drop down, and we're at 6. So I think that's probably the easiest way to do it. I definitely wouldn't want to graph this inverse function. I think that would be way too difficult, but I guess you could if you wanted to. All right, so this one is basically asking the same thing. So let's go ahead, pause the video, and see if you can answer A, B, and C for me. All right, question 1 is asking for the maximum value of the inverse. The maximum value would be the biggest y value. How high can we go? So what we want to do is look at our x values on the original function, and our biggest x value is 8, which means when we do our inverse, our biggest y value will become 8. So that's why the answer is 8. For finding the inverse, remember, if that is your input for the inverse, it must have been your output for the original. So output, I'm looking at the y, so I'm looking here at 3. Go find the graph, go see what it is. It's at 2. So the f -1 of 3 is equal to 2. And then we did it again with the 1. We came over here, found 1. We saw it touched where 3 on the x. So that's how you would write that. And last, we have what is the domain. Remember, the domain of an inverse is equal to the range of the original. So I go up here and I look at the range. Well, I went from -3 all the way up to 7, right? That we put a y there because that's what range is. And remember, inverse is switching x and y's. So I could rewrote it like this in inequality form. This is a little bit elementary. We want to write it in interval notation, and we use the brackets because we have included values at the end points. They're closed circles, okay? All right, example 4 is a little bit more involved because now we have 2 functions, and we might be talking about their inverses also. So go ahead and read through the example, and let's try and answer these. So the A starts off pretty easy. I don't have any inverses here, so it's straightforward. I got an input of 6 on the H. So come over to H, we go to the inputs, We go find 6, and we get an output of 10. So I have g of 10. That's an input, right? So we go over here to the g function. This is the g function. So I go find the input of 10. I get an output of -1. So equals -1. Uh-oh, b has an inverse, so we're going to have to deal with that. But first, we're going to start out with the h function, just normal old h. I'm going to go, I have an input of 0. There's my inputs, that's 0. My output is 3. So now I have g -1 of 3. Remember, if that's the input for the inverse, it must have been the output for the original. So now I'm looking at the y value. Where's the y value? 3, right there. Go find the function, go find the graph, go down and see what, we get a 4. All right, so we get a 4. So this one equals 4. Okay, let's try it again. Input, no inverses here, so we got an input for the g. So we go find 8. That's a big fat 0. So I have h -1 of 0. You get the drill now. It must have been over here. So now we're going to come to the h. We're going to look at the outputs because that was a y value in the original, and this is the original. So we're looking at our outputs. There's the 0. We got -1. So we got equals -1. Last but not least, everything is in inverse. So we have our first output, right? So -1. What was the input and the g function? That would have given us a -1. So I come here, find -1, go find the graph. There it is. The input was 10. So now I have h -1 of 10. So now I have another output from the original function. I want the input. So I come up here to h. I find the output of 10, go to the input, and it was 6. So this one equals 6. And that's how you work through those. I like them. I think they're kind of fun. If you're having trouble with them, do your homework, right? You'll get them.